Hello, this is the Unit 1 review for ENGR 102. A lot of this is just going over vectors, dot product, cross product, finding equations of planes by using lines, points, and other vectors. So I'll try to go through this. This very first problem is actually a Unit 1 problem. Or sorry, 101 problem. The only difference is they added a k component to it. So it's still the same kind of problem. We're just dealing with free space. So imagine we have vector B and vector A, where B1 and B2 are part of a vector B, where B1 is parallel to A and B2 is perpendicular to A. So here's vector A, here's vector B, here's B1, and here's B2. So we know that A is going to, or B1 is going to be parallel with A, B2 is going to be perpendicular, and B1 and B2 make it up. So we have a right triangle here with vector, to make up vector B, made out of B1 and B2. Remember that this portion, this length here of B1 is the same thing as the component of B onto A, because imagine we have a light here, and it's shining a light, and we're just casting a shadow onto vector A, and that shadow that is pretty much from vector B, and it's that length of B1, and that is the length of, that's going to be the length of B1. But the direction of B1 is going to be in the direction of A. So we have the length component B onto A, and it's going to be in the direction of A, so you multiply by the unit vector of A. And this is the same as the projection of B onto A. And that's how we get B1. So B1 is going to equal the projection of B onto A, which is the dot product between the two vectors over the magnitude of A squared, all times by vector A. I should probably just do not a dot, but just A right here. So everything in these red parentheses is considered a scalar portion to this overall thing. It's going to be multiplied to our vector A. And this will just equal, we'll do the dot product for each component. So it would be 3 times 2 plus 1 times -1 plus -1 times 2. So that's the dot product of A and B. Magnitude of A is going to be the square root of 2 squared plus -1 squared plus 2 squared. And that's the magnitude, but we want it squared, so we're going to square the whole quantity. To essentially cancel out the square root as we multiply the vector A, where vector A is 2i minus j plus 2k. And that's going to simplify down to, let's see, 6 plus -1 plus -2, so it would be positive 3 over the square root squared, so we take it away, so it'd be 4 plus 1 plus 4, so it'd be 9. So we really have 1/3 times vector A, so it'd be 2i minus j plus 2k. So that is B1. Now B2 is going to be based off of this equation here. So it'd be B minus B1. And that will be 3 minus 2/3 I plus 1 minus -1 j plus -1 minus 2k. All right. Oh, sorry, I forgot my over 3 here. I was looking at this thinking it was looking wrong, and I couldn't figure out why. That's because I forgot my thirds. All right, because all I did was distribute that 1/3 there to each of those two terms, and then subtract it from b. All right, so then it's going to come down to it'd be 3 times 3 over 3 should be 9 minus 2 over 3 should be 7/3 I, and then we have 3 over 3 plus 1/3 should be 4/3 j, and then it'd be negative 3 over 3 minus 2/3, so it becomes minus 5/3 k, and then you can say this is equal to 1/3 times 7i plus 4j minus 5k. So that's B2, here's B1, nothing new here, just a third component. This should be easy points. As long as you learned it in Calc 1, I guess. Alright. Now move on to the next problem. So now we're given a line and a point. So inevitably we're going to create an equation from the point and the line. Equation of a plane from the point and the line. So at first we need to get a couple things. One, we need to find the vector P0, where P0 is the point on the line where t equals 0. So I'm going to say P0. It's going to be, we're going to plug in 0 for each t in here, so it becomes 0, comma 2, comma 1, which means our vector P0 is going to be final minus initial, so it'd be 0 minus negative 1j, sorry, 0 minus negative 1 I plus 2 minus 1 j plus 1 minus 0 k. And that will equal 1 be I plus j plus k. So that is P0. Now I didn't state it, but when it says find the equation of the plane formed by P and L, we're going to need something else. So let's go ahead and look at it. We're going to have a line at some point. So we know of some point P0. I'm going to label it here. So this is P, this is L, this is P0, that's the vector. But in order to get the equation of a line, we need two things. We need a point, which we have. It's going to be P, or you can use P0. Doesn't really matter. But I want to use the point they gave us. And you need a vector, you need a vector normal. So right now, we have one vector. We can get another one by using L. So vector, I'm going to do it right here. Vector L, or I can say vector L. I'll say the line is going to give you a vector V, which is going to be based off of the coefficients of the t terms in x, y, and z, which is going to be 2i plus j minus k. It's all based off these values. So that's really a 1, that's a 1. So it's negative 1, 1, or it's 1, negative 1 for your I, or your j and k. So in order to get a vector normal, so now we have vector v here from L. And we're going to get a vector normal and use a point to create a plane. So in order to get that vector normal, you're going to label this in. It's going to equal P0 cross V, or V cross P0. It doesn't matter. You're just going to make it positive or negative depending on what order you do. It won't change much. So now N will be I, so JK, it should be the determinant of IJK, in your first row, and then 1, 1, 1 in the second row, and then 2, 1, negative 1 in your last row. So it's going to be the determinant of this, which would be I times the small determinant, that is what I call it, for your J and K columns. So it would be negative 1. Oh, oops. It would be 1 times negative 1, which is negative 1, minus 1 times 1, which is 1, then minus J. So you block out the J column and do the determinant with the I and K column. So it'd be negative 1 minus 2. And then plus K. So you block out the K column and do the determinant there. So it'd be 1 times 1, which is 1, minus 2 times 1, which is 2. And you get a vector from there. So I'll have negative 1 minus negative 1, which would be, sorry, negative 1 minus 1, which would be negative 2I. We'll have a negative 3 there, so it'll be plus 3J, and then minus K. So as our vector normal, and now we need to use this along with a point. I'm going to use the point they gave us. So this would be x naught, that would be y naught, and that would be z naught. This would be A, this would be B, and that would be C. And we plug all of those portions into this equation, which is A times x minus x naught plus B times y minus y naught plus C times z minus z naught equals 0. So this will come down to being negative 2 times x minus negative 1, so it'll be x plus 1 plus 3 times y minus 1. Be actually not plus, be minus 1 times z minus z naught, which is 0, equals 0. And the form that they want you to give this in is x, y, and z terms on the left side and all constants on the right side. So you're going to distribute each of your terms, which will look like negative 2x minus 2 plus 3y minus 3 minus z plus 0 equals 0. And then you're left with negative 2x plus 3y minus z equals, add this over, add that over, so you have 5. And normally they like to have a positive out front, so it would like to have 2x minus 3y plus z equals negative 5. But this is okay. This right here is also acceptable. I'm just saying they're going to want it like this because they're anal and they like positives out front. I don't know why. I mean, I guess it looks better, but still. All right. Next thing, we're still doing the same thing, finding the equation of a plane, but we're going to be using two lines instead of a point on the line and another point to get a vector and using a vector from a line. So we're going to use two lines. We need to find an intersection point because, again, we want to make sure that we use the point that's going to be on the plane. So to get an intersection point, you do x1 equals x2, y1 equals y2, and z1 equals z2. You don't need all three of these equations, but I like to write out all of them so that way I can find the easiest one to do. So I'll have t equals negative 1 minus 2s, 3 minus t equals 3 plus s, and then I'll have 2t minus 2 equals negative 1 minus s. I mean, you can do it any way you want. I think it's easier to start here and then move over to this one. Because what I see is that I can subtract these 3's from both sides and I'll have t equals negative s. I'll put that negative s over into that t, and then I'll get negative s equals negative 1 minus 2s. I'll subtract the negative 2s from both sides, and then I'll end up getting s equals negative 1, which implies t must equal positive 1. Alright, now this gives me my point, and I'm going to, even though you don't know what it is, you're just trying to, you just know that s equals negative 1, and that t equals 1 is where it intersects for both of these lines. So now you need to find the point for that. And use either L, it doesn't matter. I'll use L1. I want to say L1 of 1. So the right way to put it, but you can't put it that way. And that would be 1, comma, 3, comma, 2t. Or sorry, it would be 2 times 1 minus 2 should be 0. So that is a point that you'll be using for this. Write that as point. So now you have to find the equation of the plane formed by L1 and L2. So remember what I said earlier. We need a vector normal to your plane and a point to find the equation of the plane. So we have two lines, L1 L2, and we know this intersection point occurs. So we're trying to find the equation of the plane, so it's going to be this, match as a 3D space, and a vector normal coming out. And this is our point P here. So to get the vector normal, we need to have the vector that represents line L1 and vector that represents line 2. So all you have to do is get the coefficients of the variable out front. So I want to call this V1 for L1. And so that will be I minus J plus 2K. Vector 2 will equal negative 2I plus J minus K. So now we're going to do the cross product of these to get the vector normal. I, J, K. V1 first, 1, negative 1, 2. And then negative 2, 1, negative 1. So you have I, do determinant there, 1 minus 2. Negative J, do determinant there, you have negative 1. Minus a negative 4. And then you have K. And that will be 1 minus 2. So that vector will be minus I. You'll end up getting positive 3, which would be minus 3J, and then minus K. I'm going to double check that real quick before I move on. Negative I minus 3J minus K. Perfect. All right. So now we have a point right here and our vector here. Remember, this portion represents x naught, y naught, z naught. This represents A, B, C. Plug it into the equation. And that will be negative 1 times x minus x naught minus 3, which is going to be y minus 3. Oh, I just realized this should be a 2. My bad. So I'll have 3 minus 1 to be 2. So make sure I did all this right. Yep. All right, we're good. And then we'll have minus 1 times z minus 0 equals 0. Remember, distribute and then get all the constants on one side, all the x, y's, and z's on the other. So we'll have minus x minus 3 y minus z equals, and we'll have 1. So we have positive 1. Yeah, so we'll have minus 1, and we'll have plus 6, so it equals 5. Be minus 6, my bad. Equals negative 7. And then you take the negatives out of each term, because it can be like they have a positive in the front. So it would be x plus 3y plus z equals 7. That is the equation of this plane. Again, all you need is a unit vector normal and a point. Now it says find the equation of the plane passing through the point, negative 2, 1, negative 3, and perpendicular to the line L. X equals negative 1, negative 2t, y 5 plus 3t, z 1 plus t. So here, we need to find the equation of the plane passing through that point. So we have a point, now we need a vector normal. And they just said that the line is perpendicular to it. So we're pretty much given, they pretty much gave us everything we need. We're given a point P, we're given a line L, and they just said that line L is perpendicular to our plane. So we don't even need to do any cross product to get the vector normal. The vector from line L is the vector normal. So N is going to be equal to negative 2i plus 3j plus k. Because again, it said that our line is going to be perpendicular to the plane. And then we have our point, negative 2, 1, negative 3. Same business as last time. Negative 2, x minus x naught plus 3 times y minus y naught plus 1 times z minus z naught equals 0. Simplify that down, negative 2x plus 3y plus z, and that will equal, go away. So that equal 4 minus 3 plus 3, so it just should equal 4. And then we can go ahead and pull out the negative out front, so it'd be 2x minus 3y minus z equals negative 4. That is the equation of our plane. Now it says, find the piercing point where the given line L intersects the plane found in part A. Alright, so find the piercing point P0 where the given line L intersects the plane found in part A. So to do that, what you have to do is look at your equation of your plane and substitute for each of your x, y's, and z's. Because we're just trying to find the point where each of these points here have a point in time where they satisfy the equation. because there's only one point in which the line L will intersect with the plane. So it's going to be whenever everything here in the x, y, and z satisfies the equation of the plane. So it'd be, so you plug in 2, sorry, you have 2, plug in for x, be negative 1 minus 2t minus 3y times 5 plus 3t minus z. So plug in for z would be 1 plus t equals negative 4. Now we just need to solve for t. So go ahead and distribute everything. So I have negative 2 minus 4t minus 15 minus 9t minus 1 minus t equals negative 4. Look at all of the constants. So we're going to have negative 18. Add that over. So cancel these out. So we have negative 18, so we're going to add 18 to both sides. Go ahead and combine all of the t terms. And that right there will become 14t, negative 14t. So I have negative 14t equals, hey, look at that, 14. It's almost like they did that on purpose. So t would equal negative 1. So now we have to plug that t back into all of our equations, and then we'll have x of negative 1 equal, would be negative 1 plus 2, so it would be 1. Y of negative 1 would be 5 minus 3, so it would be 2. And then z of negative 1, which would just be 0. So our point P, I'm going to label this P, we'll say P1 for now, is going to be 1, 2, 0. So now it says use part B to find the distance from P to L. So to find the distance from P to L, you're pretty much going to find that by using the distance formula with point P, which we had up here. Hold up. Just negative 2, negative 2, 1, negative 3. And we're going to just plug it into the distance equation. I guess this is misleading here. Hold up. So that point P is actually not part of L. I probably should I didn't think about that until now. So this is P1. So what we're trying to find here is the distance, this, D. So to get that is, again, is the distance equation, and I keep scrolling past it. There we go. Now I can see everything. So distance D is just going to end up being the square root of, we'll say final minus initial, so it'd be P1 minus P0. Sorry, P. So it'll be 1 minus negative 2 squared plus, 1 minus negative 2 squared plus 2 minus 1 squared plus 0 minus negative 3 squared. And that'll come out to being, we'll have 9 plus 1 plus 9. So it'll be square root of 19. Remember, that's a length, so we'll label that L. Or you can say length like this. To some unit lengths, we don't know. Next problem is saying find a vector parallel to the line of the intersection of planes. Intersection of planes 4x, y, negative 2z equals 2, and negative 2x plus y plus z equals 5. So So the vector has to be parallel to the line of intersection of the planes. So again, think about it this way. We have two planes. And in the middle, hold up, we have some intersection line. So let's think about it. We can get from a plane, we can get a vector that's normal to it. So we can get one normal, we can get another normal, and then if we were to take the cross product, we get something normal to that. So if we take the cross product of those two, we end up getting this vector here. I'm going to call that V1. And that represents the direction of L, the line that we're looking for. So do N1 cross N2. Don't know why I just randomly changed color, but whatever. I decide. Now, N1 vector is going to be based off of the coefficients here. So it's going to be 4, 1, -2. Coefficients here, -2, 1, 1. All right, get our vector V, which would be I times would be 1 minus -2, -j, 4 minus 4, k, which is going to be 4 minus -2. And the overall vector will end up being 3i plus 0j. You don't have to include the 0j if you don't want to, plus 6k. So that implies vector v1 equals 3i plus 6k. So it has the vector parallel to the line of intersection of the plane. Now it says find the point on the line of intersection of the planes where x equals 0. So if x equals 0, so we're pretty much just stating x equals 0 for a fact. Like that's just what we're going with. And then we're going to use that assumption to find y and z as a point for that plane. So for n1 for plane 1, that would imply y minus 2z equals 2. For plane 2, that would imply y plus z equals 5. Now we can go ahead and find that using any method you want. Subtraction method. So I'll subtract this entire thing. I'll get minus 3z equals -3, which implies z equals 1. And if z equals 1, that implies y equals, it would be 2. Yeah, it would be 2 plus 2, which equals 4. And every case satisfies that. I'm pretty sure if I do it down here, yeah, I'll get y equal 5 minus 1, which is 4. All right. So find the point and the line where the intersection of planes where x equals 0. And that will be the point 0. Where is it? 4, 1. Now, so let's find the equation of the line of intersection. So now we have some given point. So that'd be our x naught, y naught, z naught. And we have the vectors to those. So x of t will equal x naught 0 plus 0 plus 3t. y of t will equal 4 plus 0t. And again, you don't have to include the zeros here. I'm just showing you where these things fall into place. This is the point. This is the vector. So this is x naught for your point, coefficients for your t's from your vector. Z of t will equal 1 plus 6t. Now lastly, it says find the cosine of the acute angle between the planes. So to do that, all you have to do is remember the equation of cosine theta, which is going to be, we're going to look at it for n dot of, sorry, it'd be n1 dotted with n2 over the magnitude of each other. So magnitude of n1 times the magnitude of n2. And it says acute angle. So acute angle means it has to be the absolute value. So scrolling up just for a second, we have some vector, we have some angle. It could be this angle, or it could be that angle. We don't know. It's whatever one is considered acute. So that is just, it's going to be the absolute value. Doing the absolute value will automatically find that for us. All right. So doing the dot product, so I can see my vectors in up here. So it would be 4 times negative 2 to be negative 8 plus 1 times 1, which is 1, plus negative 2 times 1, which is negative 2. So that's the dot product of my two vectors. It's going to be the square root of 4 squared plus 1 squared plus negative 2 squared times the square root of negative 2 squared plus 1 squared plus 1 squared. And I'm really writing all bad now. I'm just trying to force it to be over. And I'll end up getting us to have 9 over. So that first term there is going to be 9 plus 1 plus 4. That would be, or sorry, that's not, I can't read my own handwriting. That's a 4. So it'd be 16 plus 1 plus 4. So that's 20, the square root of 21. And then we'll have 4 plus 1 plus 1. So that'd be square root of 6. Multiply the radicals underneath each other, or find or something common between the two of them. So here I see square root of 3 in both of these. So I have 2 square root of 3 squared times the square root of 7 times the square root of 2. So that will end up becoming 3. So I'll have 3 over the square root of 14. Again, I wrote my 4 like a 9. And that is the cosine of the acute angle between the planes. All right, there's a lot of vector stuff here. It looks complicated, but just think about what the angle is. If you need the equation of a plane, just know that you need a normal vector and a point on the plane. If you're looking for a line, you just need the vector that is parallel to that line and a point on the line. Those are the two biggest things you need to know for tomorrow. There is a review. Look over if you have to. This isn't too complex in terms of concepts. If you take the time and practice it enough, you can see, it's pretty straightforward in terms of the process. But just think about what the end goal is and the steps you have to take, or the tool, whatever you're given to using that to get to that endpoint. All right. Good luck on your tests tomorrow. Sorry I won't be able to be at the SI session. I'm going to be leaving. I'm going to Cleveland for they handle some business at the Glenn Center. But good luck on your tests. Hate to miss the first SI session. But anyways, good luck. Thank you.